In this video, we're going to go through 224 part 1, which is to simplify square roots. So this in and of itself is not actually one of our learning targets, but it is a building block for one of our learning targets. So we need to know how to simplify square roots in order to do quadratic formula. So we're going to start here, and I'm going to start with this fact, this statement. So the square root of any two numbers multiplied by each other, you can split them up into the square root of a times the square root of b. So all that means is that when we are simplifying square roots, we want to find any perfect squares we can factor out. And perfect squares are something that when you take the square root, you get a whole number. And there's really two ways that you can do this. You can do this through a process called prime factorization, or you can do this by simply remembering all the perfect squares and finding them. So let's quickly write down the steps for each, and then I'll go through a couple of examples. So for prime factorization, you just find a pair of factors for whatever number is underneath the square root. You find two things that you can multiply by. Then you break each of those down into its factors until you reach a prime number. Prime numbers can only be divided by themselves. Basically, that means is like keep breaking numbers down until you can't break them down anymore. Once every single factor has been broken down, you are going to circle all pairs of matching prime numbers. So if there's two 2s, you circle them. Two 3s, circle them. And you're going to factor all of those pairs out and multiply. Okay, so I'll show you an example of that in just a second, but let's fill out the notes for perfect squares. Perfect squares, instead of like finding all the prime numbers that possibly go into it, you can figure out if you have any perfect squares involved. So determine if you can divide by any perfect square. Then you are going to square root that perfect square and factor that number out. So some common perfect squares are 4. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. And that's usually as far as you go. You can keep going up basically just by finding every number multiplying by itself. So this is our 13s. You could do 14 times 14, 15 times 15, and so on. So let's look at the example. Pause here if you need to copy any of this down. So to simplify each of the square roots. So let's start this one with the prime factorization method. So 8 I know is the same as 2 times 4. So 2 is a prime number. 2 can only be divided by itself and 1. And so I'm going to circle that. And then 4 can be broken down into 2 and 2. And I guess I should have waited to circle because we only want to circle pairs of numbers. So I have this pair of 2s, and then this one is left out. So for every pair, I'm just going to pull that number out front. And then whatever's left is going to go underneath the square root. So 2 square root of 2 is the same thing as the square root of 8. And if you ever want to just be double sure that you are correct, you can try in a calculator and make sure you get the same decimal. So the square root of 8, okay, and then 2 square root of 2. and they should be the same if you did your factorization correctly. So now this is what we called fully simplified, where underneath the square root is the smallest it could possibly be, and anything that could get pulled out is pulled out. All right, so let's do this method a little bit differently. Let's see if we can find any perfect squares. So I basically go through and I see if I can divide 18 by any of these perfect squares. And you start with the ones that are closest to 18. So 18 divided by 16. Anything bigger will give us a decimal, so I don't need to try any of those. Decimal. 18 divided by 9 is a whole number. So that means I can pull out the square root of 9. So this is the same thing as the square root of 9 times the square root of 2. 9 times 2 is 18. And the square root of 9 is 3. And so this is our simplified form. I pulled out that perfect square. And again, to just double check, the square root of 18, 3 square roots of 2, same number. Okay, so let's go back to this prime factorization method. So 2 square roots of 30. If there's already a number out front, I'll show you what happens, but you don't have to deal with it until you're done with the factorization part. So 30 can be broken down into 3 and 10. 3 can't be broken down any further. It's only divisible by itself. 10 can be broken down into 2 and 5. Again, 2 is only divisible by itself, and 5 is only divisible by itself, so these are all prime numbers. So we are done factoring. But I don't see any pairs in here. There are no pairs that I can pull out. So that means there's nothing to pull out front. This is as simple as it's going to be. So 2 square roots of 30. And last one, I'm going to do the perfect squares method for this one, just so we see equal amounts. So 192, I'm basically going to start by dividing all of these numbers. Since 192 is a little bit bigger than 169, I'm going to see what 14 squared is. And I'm going to leave a little note to myself that we stopped. This is at 13. So I know if there's anything bigger than that, I need to try 14 times 14, which is 196. And since this is smaller, we can stop there. I don't have to do anything else. So 192 divided by 169, decimal. Decimal. Any of these hundreds are going to be decimals because I'm not quite to double yet. So I'm going to go down and try 81. Then 64 gives me 3. So this is the biggest one that I can factor out. And remember, we need to square root it before we factor out, because what this is saying is that 3 times the square root of 192 is the same as 3 times the square root of 64 times the square root of 3. And the square root of 64 is just 8. So we have 3 times 8 times the square root of 3. If there are ever multiple numbers out front, you need to multiply them together. So we have 3 times 8 to give us 24 square roots of 3. And again, double check your answers. So 3 square root of 192 and 24 square roots of 3. And there we go. So whichever method you like better is fine with me, breaking it down into its prime numbers or simply finding if it's divisible by any of the perfect squares, that's fine as well. Why don't you pause it and do the you tries, and then when you unpause it, I'll have the answers on the screen. All right, and here we are with our answers. So you can go ahead and pause and check those. And I did prime factorization for each of these, except 12 I knew broke down into 4, which is a perfect square. So I pulled out a 2, square root of 3.